Okay, once we have generated the model, we can generate, among other things, a simulatable model which behaves as a performance model, as it is capable to count and produce estimations on different type of performance metrics related to time and energy consumption, power consumption. For that, we only need to select the model and then select the performance model generation option, which is present in the CONTREX, in the CONTREP menu. First of all, it's interesting to know which are the configuration possibilities we have. For that, we can go to the CONTREP configuration tab, and we have mostly two different tabs. One of them enables us to control the behavior or the position, in this case, of one of the code generators, which is the mscene and code generator. mscene is basically a tool which is capable to provide the XML description produced by CONTREP of the system architecture, system application architecture, and its mapping to the down architecture is capable to produce all the platform dependent code, which will be compiled together with the platform independent code just to produce the VIPPE model in this case. That will reflect a performance model of exactly the software that will be produced with the scene generator. And then we can also control where to dump the messages related to this mscene code generator. Once we have that XML description of the platform and we have the platform dependent code and the platform independent code, we can compile it into a VIPPE model and assess how it will behave over our model platform. We have at hand in the configuration tab a number of options which let us control the faults and the flags that use for cross-compiling with VIPPE, the platform dependent code and the platform independent code. And we can control also which compilers to use and things like, for instance, if we need to use some additional instrumentation for the entry and the exit of functions. This is required, for instance, for reporting or when we need to report response times of the application. Well, once we have seen that, we can go to the menu and then select the generation options in the performance model, and then all the generation process will start. First, all the XML files that mean a counterpart of the UML Martin model descriptions are generated. After that, all the makefile system, all the makefile infrastructure that will be required to compile both the platform dependent code and the platform independent code is generated, and then after that all the wrappers, that is all the platform dependent code, are generated. Once those three types of generations have been performed, then a fourth step, which is the compilation, the actual compilation with the VIPPE compiler tool, is produced, or it's performed. That can be seen in the console, for instance, if we trigger every single step, and specifically the compilation step. So after the compilation of this big model is performed, this progress information is ended, and then a report of that the performance model has been generated is reported to the error log, and then we have a new folder that can live together all the folders that we have renamed to avoid stepping over them, and then we see all the things that I mentioned. We have here a number of XML files with the description of the platform, with the description of the architecture of the application, how it is mapped to the platform, also the description of a parameters file, and then we have the generation of all the makefile infrastructure. Here we see also a number of libraries already compiled after the fourth step, and then the generation of the platform dependent code. A folder will be generated for each memory space. In this example, we have a single memory space, a single memory partition, so one memory space folder is generated. And then after all that stuff has been compiled, or all that functionality is compiled into a number of dynamic libraries, one per memory space. And in addition, a binary a folder is generated with a simulation script. We can, for instance, see this simulation script, and is basically containing the command calling or invoking the VIPPE launcher just to just with basic parameters to read the platform and to read the location where all the compile functionality is present or is located. And then this could be, for instance, run directly from the console, or we can just simply select again the UML file and then select the simulate menu option. As we can see here, it is possible to trigger every single generation step. We have 4 generation steps. The first one is the generation of the XML counterpart of the human multimodel, the description of the makefile infrastructure, and one of these things are being generated, especially the XML. We can generate a platform dependent code, and then once this 3 generation step has been done, all the code generation has required for generating the performance model is done, then we just compile the model with the VIPPE compiler. So as you see, all these steps are automated by means of a single generate option.